Good afternoon. My name is Kero. I'm a software enthusiast, agile software engineer. CodeChange is my freelancer company. I've seen so much software and systems over the years, but I really like the concurrency of the Beam. I also think web development is an important thing, and that brought me to Gleam. I think I have the honor of doing the first Gleam talk of this conference. So I'd like to also present you to Lucy, which is the Gleam mascot. I think she's awesome. And I also want to like to introduce you to my helper, Geese. I'm going to show you things to, well, evolve a game, more specifically board games. Board games have the board, they have the pawns, they have all these kind of things. And if you want to evolve that in a general way, you still have to pick one game to start with. So I picked a game called Oud-Hollands Ganzenbord. It's simple, it's old, I'm sure I can use and abuse the rules and things around it as I might. So this is the game I had when I was a kid, and I played it with the dice, and then you would hop your goose over the field, and when you reach the finish in the middle of the board, you would win. So I decided to pick that. It has some interesting rules if you want to model them. Things like skip a turn are weird things in terms of rules, although I'll skip over the details of that. I'll talk a little bit about model-driven development. I'll be showing quite some Gleam code. I'll have to explain you some of the rules of Ganzenbord, because at the end of the presentation, you're going to play it. Model-driven development. It's a formalized way where you don't have just your code that implements stuff. You have a model that describes the possibilities and impossibilities of the things that you're working with. And then you have an interpreter of that model in your system to actually do the things you need to do. Example, Dutch tax law has been captured. It's law, but it's been captured in a language that resembles the actual law text, but is interpretable. So they can generate the whole trees and reasons. So you got to pay this, you got to pay that, and they know about it. And they can reason about it. So another cool thing is when they want to make new tax laws, you can actually go back through the chain and see, hey, this law is going to cause conflicts or might work out. Many of those models, when people use them, have a domain-specific language, but I do not. I wanted to use a board game. So my model consists of a board, the pawns, and a rule set. Future versions might also contain cards and anything you would have in a more advanced board game. And importantly, the rules. From that model, we can create an instance. So it just picks up the board, the pawns, and all that. It's got the rules. It's going to place pawns on the board, and then it's just going to execute the rules one by one, following what the rule says. And there you have it. You can do that multiple times as often as you want to. And I have a special feature that I want to do, which is mostly interesting when you have more complex board games. I want to be able to change the rules while the game is running. And on top of that, of course, I need... and because of things like that, I want to have a user interface to modify my rules. And that's why I don't have a DSL. Yes? I missed a little bit.
Is board finite, or it can be infinite?
The question is whether the board is finite or infinite. My board is finite. The current board has simply one track, but it could have an arbitrary amount of tracks. And you could even think of boards like where you have Risk, where you don't have a track with fields on it, but you have a graph where you have connections where pawns could move over. But for me, it's finite. And even though I don't do all that much reasoning about my model, what I do like is that there is no ambiguity in my rules anymore. Well, why would I pick Gleam? well, in part because I like Gleam. It's a language that fits me. I've used similar functional languages like Elm. I've seen that functional languages usually come from a mathematical background, but they're also simple, they're easy to learn. And the particular advantages that I see in Gleam is that, one, it compiles to the Beam. It compiles to Erlang, which then runs on the Beam. I like the Beam, and I can run all my games concurrently on it, because they're independent, they're concurrent. But Gleam also compiles to JavaScript, and that gives me the possibility to run Gleam code in my browser, which allows me to build the UI that I want for my game. And Gleam is a very pleasant, modern language. The syntax is easy to pick up. The tooling around it is modern. You can just Gleam add dependency, Gleam remove dependency, Gleam build, Gleam Erlang, build me an Erlang distributable entity. Gleam test. It has interesting bits in the syntax that I'll show some of them. It's just good. So let's dive a bit into Ganzenbord now. A few of the rules. When the game starts, you put all the geese at the spot that you saw in the picture. And then one by one, the players roll the dice, they pick their goose, they move as many places as they threw eyes on the dice. But you're not allowed to go there if there's a goose standing there already. Then you just, you wasted a turn, and the next person will play. And then you have a description of the rules that say, well, in order to reach the finish, you need to roll the exact amount of eyes to get to the finish. If you roll too many, you have to move back. And you could have, I don't know, quite a few rules that vary in this. You could have a rule that says if you roll the exact amount of eyes or more, then you're in there, or etc. But this is the very specific one. If you have too many eyes, you move back. But when you do land on the finish, then you win. And now, of course, I want to express this in code, in my model. And from there on, move on, create my instance, and play the game. So, Gleam code. We roll the dice. We need to roll the dice. So this is the bit of the code that I chose to start from. You could have an action, and we create a type called action, and it has we have two ways to fill it in. A union, if you wish. One of them is that the user would have to roll the dice, and another could be not in Ganzenbord, but in other types of games where you have to choose a pawn. So this is an example of a type that has two, sort of implementations, two constructors here, two constructor functions even, to fulfill that. A second way to define a type in Gleam is with an alias. My dice values are just a list of integers. You also see that a type definition like that can take another type to use inside its definition. It doesn't mean it has to use the integers, but in this case, well, we do have a list of actual integers. If we want to construct this, it's fairly easy. I define my role, and I say it's a role. It's the function that takes a list of integers. I want to roll two dices with 6 sides, and that's what it says. And in Gleam, I am allowed to annotate my constants and variables with the type, but I don't have to. The example at the bottom is also quite a completely valid Gleam statement. Let's compose this a bit further. I now have a type that gives me all the rules of a game. It has some rules that we execute at the start to place the pawns, and when we have some rules that we execute for every turn for every player. And when the player is moving, there are I gave 2 examples on this slide because I can't fit all of the things that I need on one slide, unfortunately. There could be do require an action, which is rolling those dice. But if I want to use the amount of ice, I need some sort of reference to get back to it later. And another rule that I have is I can then move my pawns an amount of steps and reflect them at the end. Move them backwards when they reach the end. And they're going to move an amount of steps, and that then is the second one is the one that I use for the Hansa board, and you reference the roll of the dice that you made before. But another way of moving a pawn would be just to move a fixed amount of steps. It's not in the Hansa board, but it's something that does go into the generic egg model. A few more rules. If there's a condition that holds, then we execute the next rule. We execute the rule, but afterwards the condition needs to hold. Otherwise, we skip the execution of the rule. And we have a rule that the game ends with a game result, which is either which is that someone wins. One of you is going to win, so that's going to be the game result. Just to clarify, if you define a type rule in a Gleam file, you have to list all the things in one place. You can't split it into, like I did, to split it over 2 slides. That's just because they're slides. I gave the examples of the conditions. A pawn is on a specific spot on the board, and I need something to check that the pawn is alone. Resembles the rules that I presented to you before of that. And the position can be done in 2 ways. It's either a specific indexed point on the track, or it's of a specific type of the field that I'm at. All right. So how does that look when you're actually playing a game? So my presentation isn't slides. My presentation is a Lustre app. So it's written in Gleam and doing all these things. And the server that I'm talking to is an iframe that's actually a connection to the real app, which is also then the backend with a Wisp. With a Mist Mist backend, which is a web server written in Gleam, and again Lustre front end, which is the web app front end for Gleam. I would say. I need to make sure I log in. Yes. All right. Come on.
You want to sign up or sign in?
I want to sign in. This is not perfect yet, but I'm pretty.
Press sign up.
I know I can't press the other one. There are so I got this whole model with the instances, and I also built a little bit of authentication and users and players, which runs in the system, and some player management. So there's a whole bunch and I built some things on the user interface so that I can actually give a demo and let you play. To make it all look nice, and that means that some of these things are partially there. That's why there's only really a sign-up button working. But I did prepare this in such a way that I could log in with a username and a password that I preset and knew that were going to work. So I'm wondering if my network connection is working, because this is on a remote system. So I didn't want to, but I now have to step out of my presentation and have a check that my network is there. Is this, for instance, if this is yes, I have a network, and see, I'm actually trying to log in the place where I want to log in. So let's just hit this again and go back to where I need to be. I'll need to reload this, but that's okay. It goes there. There we go. I don't know. Some typo, some other thing. So now I'm actually on the server. I got through the login page. I'm looking at the Hansa board rules that are running on the server. And this is what it recreates from the rules that are on the inside. It should be clearer, hopefully, than the original rules or descriptions that I was going to give. It should be as unambiguous as possible. But yeah, well, the most important thing is what was generated from the rule set as they are encoded. Let's do a bit more of Gleam. I'm guessing that people who come from Erlang and want to use Gleam are also interested in how to work with all the processes that that the Beam provides. So that's where I picked some code examples from. There's a bunch of these things in my code base because I need my model, and my model is an actor. My instances are separate actors, separate processes. So hey, it matches. Immediate disclaimer, we're now looking at things that are running in the Beam, so this is not available in JavaScript. Since Gleam is a typed language, when I have communication between two processes, whatever goes from one process to the other needs to be typed. Erlang, you just have a term that goes from one process to the other, and it could be anything. And if it's not recognized, it's usually dropped on the floor or sticks in an inbox. Here we have a construction where there is a type called a subject. You can think of it as a channel. It is bound to the inbox of an Erlang process. And it's typed. This one, I say I'm going to send integers across. It's also very much tied to the receiving end. I think because the Erlang process has the inbox attached to that process. And if I then create another process, I start it, and the only thing I do is send a number to the existing process that created it. Then in that one, I can say, hey, I'm going to receive it. I'm going to take that channel, that subject. There's a timeout. And I'm going to expect the number 42. So yeah, what I get should equal 42. And this little bit of nice syntax here is a pipe. And that means that whatever is the result of the statement before is passed as the first argument to the function that comes afterwards. So this, whatever comes out of the receive is passed to shoot.equal as the first argument, and OK42 is passed as the second argument. Does it need to be OK? Yes, of course. I have a timeout. It can fail. What could come out is also an error of some sorts, but we're expecting it to be 42 here because we control it. And that's immediately where the GleUnit package comes in. That's the unit testing framework given in Gleam, built upon eUnit. And so we also know that we can do testing inside Gleam. Now, most of the time, we don't have one process talking to the other. We have one process or many processes that give some sort of assignment to another process, and then they get the result back, and multiple processes can do that independently, so they talk and they give something back. Tying up these subjects two ways is non-trivial. I have a blog post. The link will be available at the last slide. How does that look? Again, it needs to be typed. So I have a message. I could have many types of messages. I have just one in the example. I pass in an integer and I expect a result back. And the result, when I add a number to a number, it's also a number. If I were to have another thing that says, well, I don't want to add a number, I just want the representation of the current number that you have, and a string is coming back to me, then I could have give me the thing as a string, which only takes one argument, which is, again, something that you reply to. But instead of a integer-typed return channel, you'd have a string-typed return channel. And the thing, of course, is that whenever you try to make something that says, if I were to write a string here, the compiler is going to complain. So you can't do it. You can't ask for a string and then try inside your process to pass an int. It won't work. It's going to say that the types are incompatible. More fun things in here. Yes, so I wrote a full test here. I'll start my actor. I'm going to give it an initial state of 42 just because. The loop function is on the next slide. And then just to prove that I actually have a state that if I add 1, I get 43, and if I add another 7, I get 50, I have 2 calls in my test. Now, what's this bit? That's this function being called with the value that I pass towards my process. And this is a placeholder that makes the whole add 1 with the underscore a function that takes 1 argument. So the actor.call takes the reference to the other process, gives it a function in which the subject that's going to get the return value is put. So that the call method is creating it, and the details are hidden, are in the blog post. And then there's another timeout, and that's what it calls and does the work. And having a single underscore as a placeholder to create a function just is I think, good-looking, easily comprehensible bit of syntax that helps. It's syntax sugar function, but it's just much shorter and easily readable. That's one of the things that make Gleam pleasant. What does my loop function look like? Well, not surprisingly, it gets a message, it has the state, and you case over the message. We have pattern matching in Gleam, resembling Erlang's pattern matching. In this case, I have one type, we take the value, we send back the result, and then we have another pipe that says I have the new state that goes into my actor continue function that'll make sure that it then proceeds with the new value. Any questions about that? All right. This is the project structure of all that I have. I have one subdirectory with a backend, which has the Gleam code that compiles to the Beam, to Erlang and to the Beam. I have my UI, which has Gleam code that compiles to JavaScript. I have a shared directory which contains the definitions of my model and the definitions of my instance, because I want to be able to run them both on the backend and the front end. There's the JSON codecs are in there. And that's where we really get the benefit of having one language that compiles to the two of languages. Things that's shared, things that I want to use on the back end and the front end, is I just have to write it once and it will work. In addition to that, there's the presentation. That's this presentation. So this presentation is tied to the implementation. So that all the talks that I give around it, that I had the iframe that's now looking to the backend usually looks at localhost where it's running. And then finally, I have integration. Because if your backend and your front end can do the same language, then all of a sudden it's fairly easy to do integration testing. There's a wonderful package called Crowbot that someone wrote. So all I have to do in my test is say, hey, start me my web server in Gleam on my backend, start a browser, and then I can talk to my browser, and when I'm done, I can clean everything up. And because everything is Gleam, I don't have anything outside that looks to launch a Java backend and a JavaScript testing framework. It's just all in there. I just thought that was cool. How am I on time?
Oh, great, not terrible.
Okay, then I'll just explain the interesting little bit of syntax that we have here. That's a use arrow to the left. That's syntax sugar. That says that everything below it in the same scope is actually, we're going to wrap that in a function. And then we're going to pass that function as the last argument to the function that comes after the arrow to the left. So this crowbot defer quit launches the browser, executes the function, and deconstructs the browser. Which mostly means that I don't have to explicitly by hand deconstruct the browser at the end of my test. Which also means that if my test fails, I have no means of deconstructing my browser, but in this way I do, because defer quit will take care of that for me. So that's nice to run some things at the end of your function without magic. It's also a way to, if you know in the pattern matching that you have your case, okay, error branches, and then in the OK branch I nest my things. And with the use syntax, you can have use arrow left and then result.try, something of that you want to do. And if the value is OK, then the whole thing, the function that's underneath it, the code that's underneath it, will be executed, and otherwise not. So you could have a series of use constructs. Use, I get a valid login. Use, I have a valid file system. Use, I have a database that all work. And it makes, instead of a scary nested thing, I get a nice linear bit of code. And that's all done with a fairly nice looking bit of syntax sugar. And nothing more dangerous than that. It took me a little bit to wrap my head around that use. The first few times I tried, it's like, what? It doesn't work. But once I got used to it, it really cleans up your code in these cases. So again, some beautiful syntax in Gleam that makes the whole experience more pleasant. All right. Let's hope we're not too terrible on code. Let's play the game. 5 minutes is perfect. I'd like to invite you to go to this URL. When it asks you for an email, you just provide your nickname. I don't want your email. It's not registering your email anyway, but just give a nickname. I'll create one instance of the game, and I'm gonna view it over here. And I'm gonna wait for a few players. I have 3, 4, 5. Lovely. 6, 7, start. Okay, this is enough. So there you go. I started the game, so now there is things that people can do, and I have a backlog over here of all the things that happened. And I do hope that someone is actually. We're waiting for Jan to roll 2d6. Yeah, Jan rolls. We're waiting for Louis. We're waiting for. Well, I'm going to go here, and you can see the pawns moving. And while we're doing that, while they're playing the game, I have a button here that says "Change the rules." So I don't have actual things to change too much of it, but I can change. Say, I could change this finish to a plain cell, and then nobody can win. But I'll be nice. I'll change it back to the finish. But because it's also important that these kind of things look nice, I can actually move my fields around. And you should see while you're playing, as well as I have here in my view, that it actually moved. And I'll move it to a slightly better spot. So that all looks nice. And then I can just say I'm done with editing. There's nothing here that stops me from building the things to actually add or change rules. It's just that I modified some internals, and this still has to be done, and it's definitely on the list of things to do next. So it's a simple version of Ganzenbord. Things that I want to do next is do more rules of Ganzenbord that will include more types of different cells that are on the board. There's a prison where you can get stuck. There's a labyrinth and then you're just moved back a bunch of fields. There's an inn where you have to sleep and and skip a turn. A couple of things, and the next thing I obviously want to do is create a second type of game to run on this platform. How are we doing? Is someone getting close already? Things are happening. Lots of stuff. Cool. Yeah, people are getting close. Cool. It will finish. Yes, congratulations. Congratulations, snobs. Yes, so I already told you the things that I want to do. There's a whole series of events that's passing through the system that come in there. There's also questions that I have on this whole model-driven things. There are changes that don't make sense, like removing the whole track while the game is running makes no sense, for instance. But that's it. Thank you. These are the links of things that I talked about. And the presentation on the of what I've shown today. Top link, the tag is CodeBeam24. You'll find the presentation and the current implementation as is today.